See that tiny dot in the dark sky? Squint your eyes. Still nothing? No surprise. Even by cosmic standards, it's relatively close to Earth, yet it's still 18 light-years away. But one day, this distant world, invisible to the naked eye, might become our new home. Because it seems to have everything needed for life. They named it GJT51c, and it is a super-Earth. A small clarification. Super-Earth sounds epic, but it doesn't mean it's some upgraded version of Earth with superpowers. It just means it's bigger. Something between Earth and gas giants like Neptune. Such planets can be rocky, gaseous, or mixed. So, super is only about size, not about whether you can vacation there. This planet lies in what scientists call the Goldilocks Zone. Not too hot, not too cold, just right for liquid water. And where there is water, there can be life. At least some strange bacteria with serious survival skills. Scientists are still trying to understand what exactly makes a planet alive. It's a whole set of conditions: distance from its star, atmosphere, temperature. And GJ251c looks like a top candidate. The first thing astronomers check when they discover a new super-Earth: is it rocky like Earth, or just another gas ball like Neptune? Because so far, Earth is the only rocky world we know that has life. The second question: can there be liquid water there? Because water is the main ingredient of life. Finding a planet that meets both conditions is extremely rare. Out of thousands of discovered exoplanets, only a few fall into this golden middle. So when astronomers realized that GJ251c might be one of them, and only 18 light-years away, they were thrilled. The star of GJ251c is a red dwarf, a small, cool star about 1/3 the size of our Sun. Because red dwarfs produce less heat, their habitable zones are very close to the star, which makes planets easier to detect. They orbit faster, and scientists can more easily track their orbital patterns. Scientists have been watching this star for a long time, over 20 years of data. They already knew about one planet, GJ251b, another super-Earth with a 14-day orbit. But unfortunately, it's too close to the star to be habitable. Then, digging deeper into the data, the team noticed signs of another world, GJ251c. It looked promising. Astronomers track the tiny wobble of the star itself. These movements happen when planets pull on the star with their gravity. The bigger the planet, the stronger the pull. At first, they saw the signal from the known planet, GJ251b. But there was another influence. GJ251c orbits the star every 53.6 days. The problem is, we still know very little about this world. Its mass is estimated at about 3.8 times Earth's. But since it doesn't pass in front of its star, we can't measure its size or composition. Basically, we found its gravitational footprint, but not the planet itself. And still, astronomers are excited. This new world is bright, close, and perfectly positioned for direct observation in the future. It's like hearing noise behind a wall, and finally opening the door to see its source. But direct imaging is incredibly hard. Stars are bright. Planets are tiny, dim dots beside them. However, the new generation of giant telescopes being built right now might finally handle this challenge. For now, the team is cautious. The discovery looks solid, but they want confirmation with more precise instruments. The next step is, hopefully, to actually see this world. Well, through a billion-dollar telescope. For now, it's a mysterious, promising world. We just need to look closer. But let me tell you something else, and you definitely don't expect this. Even if there is a civilization on GJ251c or on some other super-Earth, it might be completely trapped at home. New research shows that, despite all their technology, it could be incredibly hard for them to leave their planet. Literally. The problem is gravity. It ruins everything. Super-Earths are much larger and heavier than our planet, so their gravity is much stronger. And as gravity increases, fuel requirements skyrocket. Launching a rocket from such a world would require exponentially more fuel than on Earth. On a planet with twice Earth's radius, the mass could be about 10 times greater. That means gravity would be more than twice as strong as ours. Imagine you suddenly weigh 136 kilograms instead of 68, just standing still. Gross. But this extra gravity isn't all bad. It helps hold a thick atmosphere, which means better protection from cosmic rays and radiation. Great news. If you're a microbe trying to evolve without being constantly fried by space radiation, thick air also helps regulate temperature and support complex weather systems. For early life, that's a huge advantage. But for rocket engineering, it's a nightmare. The same gravity that holds the atmosphere also chains you to the planet. Take Kepler 20b, for example, a super-Earth with 1.87 times Earth's radius and 9.7 times Earth's mass. To launch just 1 ton, about the weight of a small car, a chemical rocket would need to be 3 times bigger than Saturn V. And Saturn V is the biggest rocket ever built, capable of delivering about 45 tons to the moon. Even if super-Earth civilizations are smart enough to dream about space, they will quickly face the gravity problem. You might try building launch sites high in the mountains to weaken gravity a little. But on big planets, mountains can't grow very tall. Huge gravity squashes them flat, not letting them reach the sky. That's why the tallest mountains in the solar system aren't on the biggest planets. Mars, a relatively light world, is home to Olympus Mons, almost 22 kilometers tall. On a much heavier planet, such mountains would collapse under their own weight before engineers even reached halfway up. So poor super-Earth engineers would have to build massive artificial towers just to reach thinner air. If they had aircraft, planes, or helicopters, they could lift rockets into the sky and ignite the engines at high altitude. We on Earth are already moving in that direction with air launch systems. But what if that planet is a water world? Many super-Earths might be like that. Then their smartest species might not even live on land. They could be aquatic geniuses. Imagine dolphin engineers or squid astronomers forced to launch rockets from underwater. Something like space launches from submarines. But even with all this effort, physics is merciless. For a super-Earth about 10 times Earth's mass, chemical rockets would technically work, but the cost would be insane. You'd need so much fuel that you'd burn a huge part of the planet just to get one ship into orbit. The only real options for super-Earth civilizations are nuclear rockets or space elevators made from materials stronger than anything we know. Until then, these beings might remain stuck on their world, without satellites, without space stations, and without their own NASA. So while our telescopes keep finding new potentially habitable worlds, don't expect to see weather satellites in their orbits. If there is life on a super-Earth, it's probably looking at the stars and dreaming of visiting them, just like we once did. Don't forget to like, subscribe, and share your own experience in the comments.